this point on, if that's okay. So please speak up if that's not something you want. And so we have the facility of doing breakout rooms like we've done before in some of my other classes. And so what I'd like to propose is maybe we do 1 or 2 whole group scopings. I don't think you can see that. And then maybe we think about what are some common debugging things if we have folks that we could do a breakout room. In fact, maybe doing more strategy versus like tool debug, and we could figure out what the right distribution of breakout rooms are. So that would be my plan this morning. How does that sound? Any, can you do a digital hand up if that seems like an okay plan? We do a little bit whole group and then we do a breakout. Okay. Oh, great. Thank you so much. The questions recording for the open refine, I will do a double check of, I need to go back and look through all 30 of my recordings and make sure that they're all linked. The good news is with the open refine, the Google open refine videos that I have posted are probably better than mine. We could also do an open refine mini group here to help you build out anything that you need. Okay, so that's good. What I'd like to do before we get too far is think about next week. So as you know, these are unprecedented times, and it is the case that CCAC is trying to be novel in how they're doing open houses. And so CCAC has an open house scheduled for exactly our showcase time next week. And so my question D on our update, I'm still on share. Oh, okay. Once again, I apologize. I had a big thing happen yesterday that in personal life that was a little bit jarring. So I'm a little bit out of sorts this morning. So I appreciate your patience. So the open house for next week is scheduled from 10 to noon. And so unless there's any objections, what I would like to propose to the deans is that the open house students be provided a link to this call and they could have a sit-in. You know, a lot of times it's fun in college visits to actually be able to see a class. Like, what does a class feel like? And I was thinking that since we've done a lot of work on this, it might be fun to invite them to join us in our little breakout room. So my plan next week is to, as usual, do a share of our projects and do grade proposals. And then we are all done. For some of you, proposals. For some of you, that's next week would be your very last class of the CCAC Data Analytics degree before you're zooming off to a number of other life paths. So I'll have some sort of a goodbye message or something. I'm really going to miss working with all of you. So next week, sharing in small groups, 3 to 4, kind of like what we've done in the past in other data classes, a couple of minutes, maybe 5 minutes per person. And then we it's like that boggle game where you all the letters. So we boggle it maybe once or twice so that you can get a chance to talk to other folks about your projects. And then we do our grade proposals and then we go. Any discussion about inviting the open housers? I see a bunch of yeses on that, so I really appreciate your openness. Sure, great. Okay, so I'll email the deans about that. I have a lurking suspicion that they will be extremely enthusiastic because I have a feeling that it's hard to make an online open house rich. And since you all have rich projects, I think that's a good idea. Okay, so let's jump in with our schedule. Is anyone at a stage that they might be able to give a brief précis of their project, and then maybe do a little back and forth with Mark about your analytic plan? Can I have a digital hand raise of someone that might be willing to do that as a whole group? I'm going to lower all hands here. So what I'm thinking is, tell us about a little bit about what your project involves, and then what kind of what your key inquiry question is, and then how you plan on trying to arrive at an answer. Anyone at that stage? Zach is. Let me pull up the quick screen share. All right. Did you so how are you doing on your decisions? Oh, excuse me. I'm sorry. Yeah. No. Lou is still an unhappy kitty for being restrained and inside all the time. Oh my goodness. I know, inside life. Um, so Xiaoheng, it seems like you're still Python or R. Maybe we could ask Mr. Egge if you, I know you said that you kind of have mixed feelings about R. Do you have have you been spending more time in R these days or more Python, just out of curiosity, as we get our bearings here?
Yes, because this semester I just learned the art from Jordan, that is, who is a professor of the data 201, I think, and he teach us some very useful tools like outshining or another analytic tool function. So I could do that using the R to get some data analytic. And but because I want to use Python because I can use Python to connect the database, and instead of using Python, I just can just insert the data directly into the R, so I don't need the database. So I I have not I haven't decided yet. So maybe I will use R or Python. I'm not
Yeah.
sure yet.
Well, yeah. Well, you have to prioritize our time. So
Yeah,
I think that that's if you can go directly into R. Um,
yeah.
so maybe I think whole group might be a little intimidating. So why don't we do this? Let's do breakout rooms. And so uh, if this is amenable, what I think we'll do is we'll break up into two, and so I'll have one group uh, jump in with Mr. Egg, and maybe you can just do a round robin um, and just talk amongst yourselves of where your project is and what are your analytic strategies that you're about ready to implement, and then maybe Mr. Egg could jump on and provide a couple of thoughts there. So that might break down the. I realize that um, our online situation here is unideal. So I'm gonna have it in actually I'll have it in we'll have one so we'll have a Mr. Egg consult room, and then um, the rest of us can stay out here. Would anyone like to jump in there with Mr. Egg first?
let me just offer, I'm here happy to to brainstorm around kind of analytical methods. If there's, how you could approach answering your topic question. If you could do that with correlation analysis or with regression analysis, or decision tree might be helpful, or data visualization might be the best approach to try and get some leverage on your question of interest. Or if you have specific questions about preparing and refining your data, or creating or deriving new features from the data that you have, anything like that, I'm happy to be curious what challenges you have, and happy to offer some suggestions for the analytical methods that you could bring to bear to try and answer your top question.
Oh, great! Thank you for that overview. We're glad to have you. So let's do Sitian, Xiaoheng, and Natalie. Would you three?
All right. Maybe I could do first.
Oh, great. Do you want to do it as a small group, or are you okay doing it as the whole group?
What is small group, or
into the breakout room?
Okay. I could do the whole group.
Oh, great.
Yeah,
wonderful.
I just want a small question for that.
Oh, great. So I'm gonna make sure that you have screen sharing options, possibilities for either of you, and then I appreciate that. So, Xiaoheng, maybe you could give us a little overview of what you're thinking, and we can go from there.
Yeah, my topic is about the illumination condition of the highway or the road condition. So I just want to do some data analytics about the condition of the illumination of the road. But I found that because I found several conditions in that column of the illumination, but it is just a factor that will affect the traffic condition. So I'm not sure if I do just the single factor of the illumination that will show me some correlation between these two items. So what I think is, do I need to get more information about the road condition that will affect the traffic checking? Crashing? Yeah, crashing.
Thank you. That's great.
Or I just only need the illumination factor, and that will be okay or not. So that is my question. Is it clear, or do I need to explain more?
Very clear question. Thank you. Maybe Mr. Egge, you could talk through how you think about building a multivariate model in the most general way, and then some thoughts on that, perhaps.
So, have I understood the question correctly? That the question is how does roadway illumination or roadway lighting condition affect safety outcomes?
Mm-hmm.
Okay. Yeah. So I think the first thing I would suggest is fully define your problem statement, or make sure that you have a really well-defined problem statement, both in terms of what your variable of interest is. There's lots of different ways that we can measure safety. What we see in the database is crashes that did happen, but the database doesn't show us crashes that didn't happen. So we might quantify safety in terms of the total number of crashes that have occurred under different lighting conditions. We might quantify safety in terms of the crash rates. under different lighting conditions.
Oh.
But I think basically, the question you're trying to get to is if lighting illumination reduces the number of crashes. So we're going to our key input variable is going to be lighting or illumination. There's a number of other factors that we're going to want to control for. We'll probably want to limit our data set to only dark conditions. And I imagine that there's an attribute in the data set that would allow us to select dark conditions. If not, typically there's a timestamp associated with these. So we could filter down to hours of the day that we know it would be dark. But then there's a number of other compounding variables. It's more likely to have illumination on a busy roadway or a roadway that serves lots of traffic than on a roadway that doesn't serve a lot of traffic. And from what I've seen with safety analytics data, typically the areas that have a lot of traffic, they have a higher number of crashes, but they tend to have lower crash rates, fewer crashes per mile traveled. So you might want to think about controlling for the traffic volumes in a given area, because you're going to see, because otherwise you might find you might arrive at a finding where you're like, oh, illumination increases the number of crashes, but really the underlying driving effect there is you're seeing more crashes on busier roadways, and those busy roadways tend to be illuminated. So illumination could be a proxy for traffic volumes, and so you'd want to be able to control for traffic volumes. And I'm not sure if there's an attribute in the Pennsylvania crash data set describing like typically they call it the AADT, the annualized average daily traffic, basically just the number of cars that go down the road each day. But they're likely, so I'm not sure if there is I'm looking in their metadata document, their data dictionary, and I don't see a column for ADT, but that would be a significant variable that you would probably want to control for. If you were to arrive at to be able to draw some sort of plausible causal inference about the relationship between lighting condition and your safety outcome variable of interest. And if it's not provided in the crash database and doesn't look like it is, then you might have to go out to another data source to bring in information about roadway volumes and to be able to use that as a control. So those are a few things to kind of think about just in terms of scoping the framing in the problem. Want to think through what could confounding variables be, what's our outcome variable, what's our income variable, how are we going to filter the data, and what things are we going to try and control for.
Yeah, gotcha. So that means that I need to control or control other variable. So I could get a correlation between the crashing and the illumination. So the result might be more precise. Is that right?
Yeah, exactly. Or you should at least be aware that there is a potential confounding variable in the fact that there is a relationship between illumination and traffic volumes, and the number of crashes are tightly linked. So yeah, if you wanted to be able to draw a more robust or usable conclusion, you would probably need to control for some of the significant confounding variables like traffic volumes. But for the purposes of your exercise in this class, if you just wanted to, you don't necessarily have to control for that because you're not trying to make a policy recommendation. You're just investigating this relationship, or that's my understanding. And so just be aware that you might find you might arrive at a counterintuitive result where you see that there's a positive correlation between illumination and crashes.
Mm-hmm. Yes, because what I expect for the result might be the correlation between these two items might be the linear relationship. So, but sometimes if I consider some other factors or other variables, such like the season, such like the road condition, like the or the people age, that might affect the result. So I think that control other variable might be an effective way to let me get the result. Yeah, thank you so much. Thank you.
Yeah, no, it's a good question, and it's an important question. Your transportation agencies, they invest a lot of money and a lot of resources into illuminating the roadways, and they do it on a hypothesis that it does improve safety, but it's a question of how much does it improve safety, and does it improve safety enough to justify spending on roadway illumination. And maybe there could be another safety intervention that would also improve safety that might be more cost effective, like guardrails or rumble strips that they could invest in. Yeah, it's a great question.
Thank you so much.
And maybe I'll just continue down that train of thought for a minute. So kind of having defined the question in terms of what's our outcome variable of interest, what are our predictor variables, what things do we want to control for. My next step would be to then do some sort of exploratory data analysis. So bring the data set into my analytical environment, do whatever sort of initial joins, filters, manipulations is required to get in some usable format. For example, I think the crash data that you're getting, you get 1 year in each file. And you probably want to look at a 5-year span, 3 to 5 years, to get a sense for, just to get a larger sample size. So you might bring in the, the 2013 data, 2014 data, 2015 data, 2016 data, 2017 data, and then merge that all into a single data frame so that you have an encompassing data set. You might need to do some preparation around like processing the illumination code. I know there's a bunch of different types of illumination, and you might need to create a factor, create a character attribute that describes, that maps illumination code 1 equals daylight, illumination code 6 equals dark. And then you could filter down a bit to just the record sets that are in darkness. And at that point, you've got your data set ready to go. And you could start doing some, so you could do some data visualization, like some things that I would think about. I would want to see a box and whisker plot for or maybe just like a bar chart of crash counts by illumination condition. Maybe crash counts by hour of day to get a sense for the distribution of when crashes are occurring and under what lighting conditions that's occurring. And then you could start to do some quick correlative analysis and maybe just create a correlation matrix between your illumination types and your outcome variable and see if you see correlations there. And then finally, when you get to the modeling step, that's where you would apply, statistical techniques or something like that to be able to try and actually answer your question. So you might maybe you just build a regression model, working with typically with crashes, it's count data. So you wouldn't necessarily want to use a linear regression model. You'd want to use a Poisson regression model, which just is a different shape for your outcome variable. So you would probably want to think about using if you wanted to be able to estimate the impact of lighting conditions on crash counts, controlling for traffic volumes, you might set up a Poisson regression equation where you're predicting crash counts based on AADT and lighting condition. fit your statistical model, see if it has see how much explanatory power it has. If you see that it has a reasonable degree of explanatory power, you would probably want to check your modeling assumptions. You create some diagnostic plots to see if there's any extreme outliers that are skewing your results. Make sure that your underlying assumptions of heteroscedasticity and your other Gauss-Markov assumptions are met. And then if you get to that point where you have a model that has some explanatory power, you've checked your assumptions, then you have a finding. You have something that you could take back to a policymaker and say, like, we see this relationship between lighting condition and crashes when controlling for traffic volumes, and based on that, you would recommend more illumination or less illumination or whatever the case may be. Yeah. So that's kind of the arc of how I would envision structuring your project. Does that make sense?
Yeah, you give me a lot of suggestions. Thank you so much. Thank you a lot.
Yeah, sorry, and I know that's easier said than done, and it's maybe a little bit overwhelming to think about all of those components together, but that's I guess the sort of approach that I would think of in terms of how you would actually arrive at an answer to your question.
Yeah, thank you.
Hey Mark, could I chat with you a little bit in front of the group about measuring possibilities on your outcome variables for safety?
Yeah, for sure.
So you mentioned crashes, a crash rate as crashes per mile traveled. Could you walk through, is it mile traveled, and what if all you had was roadway length? Could you do length of roadway, or could you then talk me through how you think about assembling a outcome variable?
So crashes are typically measured in either counts, how many crashes have occurred, or as rates, how many crashes have occurred per mile traveled. And if you wanted to, if you wanted to be able to determine a rate, you would have to join in a data set that has the traffic counts for a given section of road. So you would determine your rate by counting your number of crashes and dividing that by the product of the length of the roadway and the traffic volumes on that roadway. So if you have a 1 mile long section of road and that section of road has 10,000 AADT, then you have 10,000 vehicle miles traveled on a daily basis on that road. And then you get your number of crashes per mile traveled.
So vehicles per mile is on the bottom.
Right. Per vehicle mile traveled. So it's the product of the length of the road segment, the number of vehicles.
Yes.
And I'll be honest, sometimes bringing in that sort of traffic count data is a little bit harder than you would think it would be, because road segments are oftentimes the data set that describes crashes describes the way that the road network is broken up differently, or breaks up the road network differently than your traffic volume data set might. Your traffic yeah. might have different names for the roadways, different lengths for the roadways, and so it can be tricky sometimes to actually join those two data sets together.
Yeah. Okay, so we're probably out of our league in terms of a lot of, at least in terms of my skill set of building these out into a fully completed project. So what I'm thinking is, what's going to be reasonable is for folks to have done some thinking about maybe a full analysis plan given their current question and the available data sets, and being able to have that packaged up as I would need to go through the following steps to get all the way to that kind of policy analysis. Seems like that thought exercise is probably a reasonable outcome. So I'm realizing that we're gonna try to scale this back to be appropriate to our skill levels. Very interesting. Thanks, Mark. Anyone else want to do walk through a little bit on what they were thinking about, and anyone that had a possible use of a tool in mind, but they didn't know if that particular tool was appropriate for your question?
I have some questions.
Oh, great. Please go ahead, Satya.
Hi, Mr. Egge. My topic is about the bike. So I got three data set. The first one is the traffic, the PA crash, and then I found the other on the WPRVC is about the traffic count data in the Pittsburgh, which has some like which road average daily car traffic and average bike traffic. And they have some of the speed of the car. So for me, my question first is about the correlation between the car speeding and the bike road safety. And then after the first step, I want to use the traffic count data to analyze that the top 5 or top 10 dangerous street in the Pittsburgh and the safety street in Pittsburgh, because the count data they have how many car is speeding on this road and how many back they have. So, but after I done the step 1, I found that in the PA crash, I found that I didn't find a obviously correlation between the car speeding and the bike, because I think most of the accident is on the highway, so maybe there is no bike, or some accident with the bike accident, the car is not speeding. So for the step 2, I'm not sure it's meaningful, or should I find other variables to do the step 2? And that's my question.
Okay, well, great. It's a good question, and an important question as agencies think about how they manage and enforce roadway speeds, and the relationship that has to the safety of other users on the road, if those are bicyclists or pedestrians or other drivers on the roadway. So it's definitely an important question. I think what you may need to do to be able to better determine the relationship that you're looking for is, I think what you found is that where there tend to be crashes are not necessarily the places where the bikes are, or where the bike crashes are occurring. There may be less traffic or less data about that. In general, bicyclists and cars try to separate themselves a little bit. If you're a bicyclist, you probably would prefer to ride on a road with less car traffic than a road with more car traffic. And then in the crash data set, because crashes, if you have a busier road, more crashes on the road. There's just kind of the separation. The bike traffic and car traffic tend to separate each other out. You'll see most car crashes where you have the greatest number of cars. So you need to come up with some way of being able to I guess, control for the amount of bicycle traffic. So one way that you could do that, maybe the easiest way to do that, would be to look through the WPRDC data and filter down to the roadways that have significant, I think they have bicycle counts. So you can filter down to the roadways that have significant quantity of bicycle counts, and maybe you'd find that there's 50 streets in Pittsburgh that have more than 50 cyclists per day. So you figure out what those streets are, and then you can bring in your crash data. And it'll be a little bit of a tricky join because they're probably not quite the same segments. But if you could join your crash data to those streets that have a significant amount of bicycle traffic on them, then you'll probably start to see more of a correlation between speeding vehicles and bicycle crashes or injuries.
Thank you so much. I will try to do that first to find the street, and then put the street into the crash data to analyze it. So I think I should switch my step. I should do the step 2 first, find the street, and then doing the step 1 using the crash data. Is that?
Yeah, exactly.
Thank you so much. I didn't think about this before, so I think I found the way to how to figure out my problem. I stuck here for 2 weeks.
Cool. And the other advantage of doing that kind of filter and join at the beginning of your analysis is that it will make your data set a lot easier to work with, because it'll filter down. There might be a million crashes in the PA crashes data set, but if you filter down just to your 30 streets of interest, maybe you'd have 1,000 crashes, and that's a much easier number of records to work with than a million.
Thank you so much. Because I do this question because I found a research, I think is from the CMU project. They do long-term sustainability of bicycle infrastructure network. So they have a systematic design, and they have a final project. It's about, they have a map about the city safety road for the bicycle. But they use a lot of different, I don't know, I think they do the machine learning. So they have a street like they, sorry, can I find this?
You share out your screen if you'd like, Satya.
Oh yeah, I copied the link of that, the final project of it.
Oh, great.
Yeah.
Thank you, Satyan, for asking such a good question.
Yeah, they have a outcome picture. I don't know, they use, I'm not sure, can I use they use the G's? I'm not sure what the app is.
I'm just taking a peek at this report as well. Thank you again. Anyone else have a interest in doing a quick consult with Mr. Egge? Mark? I'm afraid I'm gonna if we don't have any other discussion with Mr. Egge this morning, I'm gonna ask if we could reconvene next Monday, or on Monday evening. I'm not in a position to be able to hold class right now. So could I could we reconvene Monday evening and take stock of what would be a reasonable product for Saturday? Could you raise your digital hands if you could reconvene on Zoom at Monday at 6 p.m.
Eric, sorry, our art class is on the Monday for final presentation.
Okay, could we do it? Could I check in with you individually after that class? Could you just give me a call at the shop?
Yeah, of course.
Okay, that's great. And then, well, thank you. Okay,
if we have this time, we could potentially dive into the first question about illumination and crashes a little bit more. I'd be happy to share my screen, maybe give a demonstration of what it would look like to move through a few of those analytical steps.
Oh yes, we'd love that. I just I'm if you'd be able to do that, that's great. Xiaoheng, I'm assuming that would be okay with you.
Eric, we can stay on if if you need to go.
Okay, could you do that? Actually, I'm just gonna keep it recording, and then when you're all set, we'll be done. So I'll just put myself on mute and turn it over to Mark and do some screen shares, and I'll post that video as soon as it's done.
Let me make sure that I can share my screen here. Oh, I may have to rejoin. Let's find out. Then
I have enabled.
I'm probably gonna have to exit Zoom and rejoin to be able to.
Oh, Setian, are you done sharing?
No.
Oh, here we go. Sorry.
I think Mark got it.
I upgraded my operating system about 2 weeks ago. It's introduced some challenges. Okay, cool. Well, yeah, Eric, we're I think good to go from here. So maybe we'll walk through some of the steps. Maybe do just kind of a quick demo of how I would approach the question around identifying a relationship between illumination and crashes, and then we'll wrap up after that.
Thank you, Mark. I really appreciate the demo. I didn't want to put you on the spot for doing a demo.
Yeah, well, hopefully this will be useful to kind of see the approach. So I'm assuming that the data set that you all are working with is just the PA crash data. And can you all see my screen here that I'm sharing?
Yes.
Yes. Yep.
Okay, cool.
Yes.
So, and is this the data set that you've been working with?
I don't think it's the same. It might be the same one, but it looks
Yeah,
different.
it's the crash details data set from like 97 to now.
Oh, okay, gotcha. So you've got a data set where that's already joined together. So as Xiaoheng was talking, I just downloaded 5 years worth of data off the website here, and let's see. Cool. Thanks for sharing that. I may just roll with the data that I downloaded already, only because it includes a pretty nice and descriptive metadata document here that describes what all the fields mean, and it may be the same in the other data set. But I downloaded 5 years worth of annual crash history data. I can show you. I downloaded 2012 through 2016, and there's a few different data sets that come in the zip file, but the one that we're interested in is the crashes data set. It has all of these different attributes about the crashes that have occurred. So I'm doing this in R. So the language is R. The workbench tool that I use here is called RStudio. It's an open source IDE for working in R. You can do all the exact same stuff with Python and pandas, but R is the tool that I use most of the time. It's a pretty good tool for doing this sort of data analytics work. It's not a good tool for building things, but for data analytics, it's pretty slick. So I'm just going to read in the data sets. I use a library for R called Data Table. That's a great extension for R that makes R a much more powerful tool for working with large data sets, rather than just using a base data frame, which is an object type that was built in R like 20 years ago. Data Table is much faster. And it includes this cool fread function, which reads in CSV files really quickly. So the first thing I need to do is bring the data in. So I'll use the data table library. And what I've done, because I have 5 years worth of data and I need to combine them, is I just created a simple for loop that goes through, and it'll loop through 2012 through 2016, and then use the fread function to read in the associated CSV file. So this is running in the background, and it's going to read in each of these CSV files into a list, and then all I have to do is use another data table function that will combine these 5 files into a single file. And so now I have this data set. It's 627,000 crashes that occurred between 2012 and 2016. Described using 89 different variables. And something that I like to do, kind of just at the outset, is a little bit of exploratory data analysis to get familiar with my data set. So I often like to produce summary statistics of some of the data, the variables or attributes that are in the data set. And I've done this enough that I've just built a simple function that I can use to create summary statistics of all the attributes in my data set, as well as summary plots. And so I'm gonna run that right now, my summary plots function. I'm gonna pass in like the crashes file we just read in, and I'm gonna write this to a folder called plots.pdf. Now I'm going to need to create that folder so this runs correctly. So when I run this little function that I've built will go through each of the 89 variables in the data set and produce just a little summary plot of each of these. And this provides me with a way to just kind of quickly look at the numeric attributes that are in the data set and get a sense for what's in there. So I can see that there's county data in here. It looks like there's 70 unique counties, and some counties have much higher numbers of crashes than others. So these are all little histograms of the data set. You can see it's coded by municipality. Here's the crash year. So we have kind of an even distribution of crashes. It looks like the overall trend is going up from one year to the next, but there were fewer crashes in 2014 for whatever reason. Crash month, looks like maybe there's, well, actually, I don't know. I'm curious, what do you all see in the crash month? What trend is here?
Looks like the winter months are worse.
Yeah, that's kind of what I'm seeing as well. But the highest numbers are January and December. And then day of week, I'm assuming this, well, I don't know. I'd have to look at the, here's the metadata document. So day of week, 1 is Sunday, 7 is Saturday. What what information do you see in the day of week table here, or histogram?
The weekends are pretty.
Yeah.
Yeah, it looks like Fridays have a lot more crashes than other days of the week.
It's so useful.
So here's a little bit of useful information. So hour of day, if we look at this, it looks like there's more crashes in the evenings. But what other piece of information do we get when we're looking at this plot about the hour of day, which is presumably coded in like 0 through 20 or 1 through 24?
Of an outlier.
Yeah, exactly. So we're gonna have to do some data cleaning here to be able, if we wanted to look at hour of day. There's probably some values here that are, I'm guessing, probably coded 99, indicating that that there just wasn't an hour, like maybe when the officer arrived on the scene, he or she forgot to record the time of the crash, or for whatever reason it's not in the data set. And we could see actually the unique values of that. I like sometimes to just create a table, which is a tabular summary of some of these. So if we created a table for the crashes hour of day, so we can see it's coded 0 through 23. And then, yeah, sure enough, here's some 99 values. So I might do some initial cleaning here and say, well, we're only interested in looking at crashes where the hour of day is known, because we're specifically interested in, like nighttime crashes. So using data table, the syntax here is I'm gonna filter based on hour of day. And I'm just gonna keep all of the records where the hour of day is less than or equal to, I'm sorry, not 99, 23, where there's a valid hour of day. And when I execute this command here, which I will do with a shortcut on my keyboard, you can see that it reduced the number of crashes in the database from 627,000 to 623,000 roads. So we've gotten rid of those kind of outliers or invalid data points. The other information that we're interested in here, we might want to control for weather, we might want to control for road condition. So here's our illumination variable. It looks like the vast majority of crashes occur under illumination condition 1. If we look at the data set here, that's daylight.
Oh, it's daylight.
And then crash condition 2 is dark, no street lights. And crash condition 3 is dark with street lights. So we'll probably want to filter our crashes down to just these 2 illumination conditions. And we can see that there are quite a few number of crashes that are either condition 1 or condition 2. We created a table, crashes, illumination. Let's see, yeah, there's about 100,000 each with 1 and 2. So let's just filter our crashes down to those 2 illumination conditions of interest. Crashes, and we do illumination. I'm going to use the in operator in R to be able to choose from multiple values to filter by. So we're going to filter down to only those crashes that correspond with the illumination variable is equal to 2 or 3. And if you've used R at all, if you were working with a base data frame, you would need to specify both the rows and the columns. But with the data table library, I can just put my filter right here within the brackets that say, all right, we're going to filter down to just these crashes. So now I can see this number jumped, it reduced from like 627,000 down to 200,000. And we're starting to get our data filtered down to like just just where we'd want to do some analysis. And I might rerun and create these summary plots again now that we have the data filtered down just to our crashes of interest. And that refreshed in the background. You can say illumination now only 2 or 3. And you can look and see if there's any significant changes here. Looks like the trend that we saw in terms of the number of crashes per month is more pronounced if we're looking only at crashes that happen after dark. It also looks like the trend we saw with respect to the weekends is more pronounced. And we can see a distribution of the hours of day in which it's dark on an annual basis. Cool, and I'm just looking through here really quick to see if we do see any sort of information about roadway volumes on the roads. I'm guessing that we won't, but so these are work zones. These are the number of vehicles involved in the accident.
This plot is so useful.
Here's information about whether or not the people were wearing their seatbelts or not. So, interesting question. Latitude, longitude of where this occurred. Roadway surface type. Okay, so I don't see anything else in there that's, I don't see anything here that describes the, how much traffic volume is on our section of road. So we'll probably only be able to look at the overall crash counts under different conditions, but there's still some potentially interesting analysis there. Weather, road condition. So at this point, we have our data set filtered down to the 200 crashes that occurred between 2012 and 2016 that either occurred under they all occurred at night. About half occurred under lighted areas and half occurred under non-lighted areas. And I'm just trying to think if there's if you were to look at the road network, Pennsylvania, all of the roads on it, this doesn't show the roads, but maybe there's 5,000 miles of roadway, or let's say 10,000 miles of roadway, of which probably only 1% or 2% is illuminated. Let's say 10,000 miles of roadway, 1,000 miles of illuminated roadway, and the rest of the miles of the road network are all kind of in rural areas or in areas where there isn't any lighting. Yeah, in our data set, we see that that about half of all of the crashes that occur in our data set happened under illumination. So already and I don't know the exact mileage, and I'm not sure how we could find the exact mileage of what portion of the road is illuminated, but already we're getting a sense that that crashes tend to occur disproportionately in areas that have roadway illumination.
Thank you so much. It's so useful for that. Thank you for the demo.
Does anyone have any ideas or thoughts about how we could kind of control for the volume of vehicles on the road?
I have a question for forecasting. So if we have a data and do some correlation between these two, and can we do some forecasting using R to do that or not? I have no idea about that. Just a little bit, yeah.
And there's a few different ways that you could forecast into the future. One, if we're fitting a statistical model, and maybe we'll look at that in a few minutes. If you're fitting a statistical model, once that model is, let's say that we created a model that predicts the number of crashes based on illumination and traffic volume. And once that model is trained or fit, you can pass in new data. So you could say, well, what would happen to crashes if there was 25% more traffic? You could create a new data set, pass that into your statistical model, and use that to predict a future outcome. The other sort of forecasting that you could do would be time series forecasting.
Oh, yeah.
In which you basically make an assumption that the past is predictive of the future and there's some sort of trend. And there's a lot of libraries in R that make it very easy to do time series forecasting. So one variable in here that that we could potentially use to our benefit is maybe the municipality attribute. That may provide us with a way to separate out or normalize for the volume effects that we're seeing in our data. Let me see if this municipality. Oh, all right, so here's all the municipalities. And I wonder in our data set if we see if this municipality field is filled in for all of the records, or if there's records where it's empty because it's the crash didn't occur within a municipality. Let's find out. Use the you also just count the number of let's make this easier on ourselves. So one of the nice things about the RStudio IDE is that anytime I want, I can inspect any of the objects that are in my environment. So I just clicked on this and it opens up a nice little window here that shows me the data table that we're working with. So if I wanted to answer a question about if this is filled in for all of the records or rows, I can just open this and inspect it and sort this a couple times and see that the municipality field is in fact filled in for all of the fields, or I'm sorry, for all of the records. So that's not going to help us separate things out. We do have latitude and longitude for all of these crashes, and we could bring in a data set that includes the traffic volumes and spatially join all of the crashes here to that data set. That's probably
yeah.
that's probably going to be the easiest approach. And so let's take a look at that and see what that looks like. So a lot of times, we can do the spatial processing in RStudio or in R. There's good libraries for working with spatial data, but a lot of times I like to do my exploratory analysis using a GIS environment like QGIS. So why don't we can take this data set that we created, where we filtered things, and let's write this out. So we're going to use the fwrite command from data table and take crashes and write this to out crashes clean.csv. So we just wrote our data set here to disk. Here's our shapefile of, I just brought in a shapefile that I happen to have access to for Pennsylvania that I know has traffic volumes. So this is from a data set called the NPM RDS, the National Performance Management Research Data Set. And so it has all of these road segments in here, and one of the attributes that it has for the road segment is AADT. And I can show you kind of what that looks like. We could just quickly symbolize this on a base map where we can actually see what's happening here. We could symbolize this, do a gradiated symbolization by AADT. Change the color ramp so that things are brighter, I don't know, green if they have higher traffic volumes. Modify this symbol and make it a little bit thicker so we can see it on the map. Okay, so here's statewide traffic volumes. See that most of the traffic is occurring on the far eastern or far western edge of the state. If we zoom into Pittsburgh here, we can see that the interstate is carrying a lot of traffic volume, and some of the other roads in our data set don't carry a lot of traffic volume. So now that's our traffic volume side of the house. Then we can bring in that data set that we just parsed through. So we're going to bring in a delimited text type data set because we're reading from a comma separated value file. Projects, CCAC out. So here's the data set that we just created. And we know that this data set has latitude and longitude in there, and QGIS figured out that these fields correspond. So we can just add in our CSV data set here with the latitude and longitude of all the crashes. Hopefully. Let's zoom to layer. Okay. So does anyone know what's happening here?
Why is so slow?
So we've got a bunch of crashes that are showing up in Kyrgyzstan. You can see that the shape of the crashes is roughly coincides to the shape of Pennsylvania, but it's all getting mapped in Kyrgyzstan. Any ideas why?
Is it the latitude and longitude are off? They're swapped?
Yeah, I bet if we look at this, We can see that the latitude is equal, but I'm guessing that the longitude is missing, is coded in positive, or is coded in degrees east, and it needs to be coded in degrees west, off by 180 degrees. So we might be able to transform that in QGIS, but oh my gosh, what's going on here? Probably the easiest thing to do, since we already have this data in R over here, we can just take crashes, and we're just going to multiply longitude. You just multiply longitude by 180 degrees. Wow. There we go. Oh, maybe there's multiple fields. I don't know. Decimal long. Let's look at this one more time and make sure there wasn't a different field. Let's try the decimal latitude and decimal longitude fields and see if that does the same thing. And if so, we can just multiply longitude by -1 to move that over into the Western Hemisphere. Ah, no, so that I just used the wrong fields there. All right, so now we have our crash data set in Pennsylvania. We can move our road network on top. And start to see that, oh, hey, like here's a bunch of crashes that have occurred on, this is 395 or whatever the interstate is there. So now we want to join the two data sets together. And so if we zoom in, we can see that these latitudes and longitudes for the crashes are pretty, you know, they're close to the roadway, but they're not exactly on it. So I don't know if you've done any spatial analysis, but does anyone have a suggestion for what we would do next to spatially join these point crashes to roadways? So right now we have a roadway that is its line features, and in kind of GIS space, line features have zero width, they're just linear. And so if you were to try and join a point to a line, unless that point happened to be precisely on that line, it wouldn't join. So commonly, what we do is we'll create a buffer around our line features to increase their size. So then we have a polygon, and we can join the points that fall within that polygon. Typically, so right now, let's see, let's run that again. Both our points and our lines are projected in decimal degrees, and so usually when you're buffering, you want to reproject into something that's measured in meters or feet. And the reason for that is 1 degree of latitude is not equal to 1 degree of longitude. But we'll skip the reprojection step for now and just kind of proceed with buffering things in decimal degrees, which is not something I would do if this if this was something that, you know, I was going to go and present at the state capitol. But for our purposes today. And I'm just doing a couple experiments here to come up with a buffer width that I like. So that looks pretty good. So you can see, if we pulled our crashes up, you can see that a lot of those crashes are now occurring within these buffers that we just defined. I might make things a little bit wider, create flat end caps. Let's make this a little bit wider. That. Sorry, I'm confused about. Okay, so here's our buffer that corresponds to our road segments. We've got some crashes on there. Now we can use QGIS to spatially take the crashes that overlap with our road segments and join them. So to do that in QGIS, we use the join attributes by location tool. Our input layer is this buffered. Let's get rid of these other layers in here just so they're not causing any confusion. Do that again. Join attributes by location. So here's our input layer buffered, our join layer crashes, and we can leave the rest of this alone. And this is warning us that there isn't a spatial index on our input layer. So this is running pretty slowly. Yeah, it's really slow. So we can create a spatial index for both of our files here. It's not normally something you have to worry about, but because we do have 200,000 crashes in our data set, the spatial index will improve performance. Any questions about what's happening with the? Are you familiar with the concept of doing like a spatial join?
Yes.
So in a database, you might join join attributes based on a unique identifier. Like maybe if we had a roadway identifier, we could join all of the, you do it based on a unique identifier, a unique key. But in a spatial context, you don't have that unique key necessarily to join on, but you can define a region and say if our point attributes here fall within the regions that are defined for our line segment buffers, then we can join those two attributes together into a single record. And so, now that I'm thinking about this, I'm doing this maybe the wrong way. I'm joining the crash points to the lines, but I think really what we want to do is we want to join the lines to the crash points, because we're trying to get the traffic volume data here joined to our crashes, but we want to keep crashes as kind of our unit of measure. So apologies, we'll do this again. So we're going to take crashes as our input layer and join it to roadway, and we'll change this so it only joins in the event where we have multiple overlapping roadways. We'll just take the first one that it happens to overlap with. And 200,000 records seems like that's a reasonable number of crashes to work with. This is running pretty slow. Sometimes what I'll do if I'm working with a large data set, sometimes I'll just subset down to maybe take one particular county or randomly take the first 1,000 records of the data set that I'm working with so that I can go through and do all of the data processing steps and kind of define the code for what needs to happen. And then go back and rerun the process with the full data set once I've gone through the iterative process of developing my data processing. Because as you can see, sometimes this process can be quite slow.
Yeah.
Quite slow. I mentioned that this can be done in R. That's true. Maybe we'll set this up and run the same thing in R and see if that runs any faster. So in R, there's a few different packages for working with spatial data, but far and away the best package is a package called SF, Simple Features. So we can read in the shape file of the roadways using the gdal stread command, and this is going to be shape. Right. So I just read in this the same shapefile that we were looking at in QGIS that has all the different attributes like AADT. So we just read this into R, and we can buffer this using the stbuffer command. So we're going to take our shapefile, and we're going to buffer that by, what do we say, 3/10,000ths of a decimal degree. Let's see if that was right. Parameters, looks like 4/10,000ths of a decimal degree. And let's make sure we do an NCAP style. I'm actually not sure what the, we want to have square end caps, so we're not creating overlapping road segments, but I don't know what the argument value is that I should pass in here. So I can just use question mark. This is the name of the command that I'm running, and that'll open up the help file for it. So if I look through here, the default end cap style is round, but it looks like the options are round, flat, or square. So we want to do flat. And here it's producing a warning. This is what we were talking about before, that buffering longitude, latitude encoded data it's not a good practice. Ideally, we would reproject this into like a UTM projection or a state plane feet projection. But for our purposes today, I think it's good enough to work with. What we can do with QGIS here is just, so the crash data set here that has the latitude and longitude, we could use the SF package in R to take that latitude and longitude data and turn that into spatial data. But we could also just create a shapefile using QGIS here. And that's going to be easier. So we'll call this crashes. So this is going to create a shapefile that includes the latitude and longitude of all of our crash point features here. Hopefully, I'm not sure if that will run. Yeah, okay, that's running. So we can read in the shapefile that we just created. The same thing, st-read, shape, crashes, shape. Which should read in a spatial object with, you'd expect 202,000 rows. Yeah, okay, so there's our crashes shapefile. Sorry, was there a question?
Is this a mapping when it outcome? The SF library?
Yeah, so yeah, the SF is it's a mapping library. It's called Simple Features, and it's for working with spatial data within R. So it has all sorts of useful features. It lets us read in shapefiles into the analytical environment here. And all a shapefile is it's a data set that has attributes, but one of the attributes is a geometry attribute. If you look, crashes shape, this is the exact same data set we were looking at before, except it has one new attribute called geometry. We created that by bringing things in QGIS, encoding the latitude and longitude, and then saving as a shapefile. So you can see the geometry here is a point type, and each of these is a latitude longitude pair. And because we were running into some performance issues here where this spatial join is taking forever, maybe we'll just filter our crash data set down to Allegheny County. That seems like a reasonable thing to do.
And I have a question.
Yeah.
And can we use the shapefile and do the geo visualization in R?
Yeah, if you want to visualize things in R, there's a library called Leaflet that we can use to kind of visualize things. It's kind of awkward to visualize things in R. If you want to visualize, it's better, I think, to use a GIS workbench like QGIS or ArcGIS. But I can show you how Leaflet works. One of the limitations. Oh, go ahead.
Because I know that R provide us a R shining, so it could create a dynamic web page. So if I could do a geo visualization, I could put that into the R shining, right?
Mm-hmm. Yeah, absolutely. Yeah, one of the cool things that you can do with R Shiny is it's pretty easy to connect an underlying data set and to create like a dynamic interactive map.
Yeah. Sorry to interrupt that.
Yeah, no, it's I think it's really cool, and I actually do a fair bit of that professionally, creating shiny based applications. And we could look at that. So I'm going to filter things down to just Allegheny County to keep things tractable. So we'll take this crash shape And we're going to filter it down to only the records where county equals 2. Okay, so now there's only 20,000 crashes, and that's a more reasonable number. We can use the leaflet library to view this stuff. I don't use leaflet a lot, so I'm not sure if we can do this. Leaflet. Everything for a moment. I don't quite remember how to add in data layers. So symbolization, add circle markers. Right, I want to add point markers. I think that's right. Maybe not. This is part of the reason why I prefer QGIS, is that you don't have to remember points like polylines, pop-ups, and circle markers. You don't have to remember any particular code to be able to just bring things in and visualize them in
Cool.
So that's a little ugly. That's probably not quite what we want to do. I'm having to look up the yeah, that's cool. Let's add some circle markers in. It's like our cluster markers. Yeah. These clusters are actually pretty cool. Let's see if this works.
No way.
So,
Sorry.
automatically grouping these points into clusters. As we zoom in, you see like there's a cluster of crashes here. And I think if we keep zooming in, eventually it'll put points on the map. So yeah, you can definitely visualize your spatial data using R. We can connect this into a Shiny application and kind of do some interactive filtering on it.
Yeah, thank you.
But back to our question of interest, let's see if we can create a file called J, which is, we're going to st join. Let's see if we can join together our buffered road network and our shape file. So we will take crash shape as our first input, and then our road network buffer as our second input here. Am I doing this right? St join. Yep. So we're going to join it, and it looks like it defaults to doing a left join. Sorry, let's see. The join, there's the predicate that's going to default to intersects. Let's say left. false. So it's saying that our projections for the two files are different. So we may have to reproject our data after all. So we can look at the find out what the projection of our crash shape file is. This is in Web Mercator. Our buffer. Okay. So actually, our buffer is in true Web Mercator. This is also a web-based or latitude longitude reference system, but it's based on the NAD83 datum instead of the WGS84 datum. So we just need to, we can just reproject our crash shape file here into this format. I think that happened because when I could have fixed that in QGIS when we exported that crash file. I wasn't, yeah, I should have changed this to the project CRS. Let's go ahead and do that in QGIS rather than reprojecting in R. So, no, I don't know why that didn't work. We'll have to. Sorry. We're going to delete this file and we'll export this one more time. WGS84. So as you're probably getting the sense that this is pretty typical for how this analysis, how a project for like most of the work is kind of on the front end of doing your data processing. You know, like we're having to spend a bunch of time to join together these two data sets of our data set with crashes and our data set with traffic data. So it's a lot of data preparation and really only a little bit of analysis.
Yes.
All right, so let's read in our crash shape file again.
It was.
It takes a moment to read in. All right, so now if we run just this tiny little bit of code here, stcrs crash shape. All right, now we have something that's actually in EPSG 4326. You can test this logic and see if our two shape files are in the same projection. They are. We're going to filter down to only the 20,000 records in Allegheny County. And let's try our join again and see if this works. Okay, yeah, so there looks like about 10,000 of our crashes successfully joined. Comment out this leaflet bit here. Oops, that's not one. We can look at our join here and see, all right, so here's all of our attributes that we get from the crash file. You'll notice that the names here got truncated because of process of converting them to a shapefile. Shapefiles only support row names of up to a maximum of 10 characters. All right, so this is all from the crashes file, and then over here, here's all of the data from our roadway shapefile. So now we have a data set that has AADT values in it, and crashes. So we could, if we wanted to see if there was a correlation between let's look at our distribution of roadway volumes in our across our network, and then we can look at the distribution of where crashes are happening. So our shapefile here, I like creating histograms to visualize the distribution or spread of data. So if we created a histogram for our Pennsylvania road network based on the AEDT value, you can see that most of the roadways in our network have crash or have traffic volumes in kind of the 0 to 20,000 cars per day range. And then there's kind of a long tail that there's some roadways here, maybe the interstates near Pennsylvania, that have traffic volumes upward of 200,000. We're to look here at roadways or where crashes are occurring and look at the same AADT data. I bet we're going to see a different distribution where the higher traffic volume roads are more heavily represented. Yeah, somewhat, not entirely, and I'm not sure why this is showing up in scientific notation. Let's run that again. All right, so yeah, here we're seeing that a lot of our crashes are occurring on these higher volume roadways. They have more of a right distribution on this. So going back to our question of where crash rates differ under illuminated conditions or not, I think we actually want to go the opposite direction. So here we've joined the roadway attributes to the crashes, but let's invert our perspective and instead look at join crashes to road segments. So we can join our shape, buffer, and shape. And we'll do the same thing where we'll only keep road segments where there's at least one segment that's joined. And then we're going to need to do a little bit of aggregating. So this just created one record for every intersection between a crash and a road. So now we have like 10,000 records here. But if we were to look at, so the unique identifier for these segments it's called the TMC, traffic message channel. So we have 10,000 records or 13,000 records, but that only corresponds to 1,300 unique TMCs. So let's go ahead. I'm just gonna aggregate some of this data back together now that we've joined it. So we can take as data table. So I'm going to create a new data table object that has our resulting data set here. So it's got 10,000 observations, and then we can summarize this. So let's say count equals .n. We'll summarize our data set by TMC and ADT. So we just, what we just did here is we created a, and sorry, I kind of glossed over that. This is basically like a SQL query where you're returning the count of roads, grouping by TMC and ADT values, so our unique road segments. And this produces a new data frame where we have the TMC segments, the traffic volumes, and the count of crashes. And there's one more piece of data that I should have brought over. That is the length of.
Wait, Mark, can you pause there?
Yeah.
That was breathtaking. I want to let you know that working, Mark and I shared a computer wall, so we faced each other into our monitors. And if you had a SQL problem, Mark could you read your SQL and come up with, oh, you need to do an inner query and then group by this and pass this. It's someone who knows his tools very well. Very well. Thank you. Keep going. I appreciate this so much. Wow.
Yeah, and that's a good point, Eric. That I have the benefit of having done this for years, and in particular working in R professionally for the last 2 years. It's taken a long time to get to the point where I'm able to do a lot of this just by kind of knowing the commands. And I got here by reading Stack Overflow for like 10 years. Like, how do I do this? Go read Stack Overflow. I'm like, okay, I'll try it. And then, you know, you do that enough, and eventually you just kind of, you start to know the commands. But it's really only because I work with this professionally that I've gotten to the point where I don't have to constantly be looking things up. So if we wanted to get our crash rates, we'll need to get vehicle miles traveled, which is just the number of vehicles on the road segment times the length of the road segment. And then we can derive a crash rate based on count. Let's give this a better name. We'll call this crash count. Crash count divided by VMT. And typically, crash rates are recorded per 100 miles vehicles traveled, or I'm sorry, per million vehicle miles traveled, or per 100 million vehicle miles traveled. So let's report this in 100 per million vehicle miles traveled. Oh, did I not run that? Okay. All right, so now we have rates for all of our road segments, but we dropped one key piece of information that we're interested in, and that is illumination. So let's go back and do a little bit of reprocessing and bring over our illumination attribute, and then we can start to look at crash rates for under illuminated conditions and non-illuminated conditions. So our counts file here. So we probably want to group things by one more, which is going to be illumination. And that field name got changed because of the shapefile conversion there. So now for any given TMC, we have 2 rows we have a row where it's under, where the crash was illuminated, and a row where the crash was not illuminated. And then we have counts for each. And then we have crash rates as well under illuminated and non-illuminated.
Wow. So cool.
So we could, maybe we could look at a box and whisker plot to get a sense for how the rates differ between illuminated and non-illuminated conditions. Let's see if I remember. Counts. Is there a formula? So we do a box plot of counts where we want to see rate by. See if I'm doing this correctly. No. Okay.
Rates by Illuminati.
Oh, I got my order wrong. Formula data equals counts.
Oh.
We've got some pretty serious outliers here in terms of crash rates. To get a useful box plot, we might have to just look at a subset of the data. So we can just filter our data here on the fly and say we only want to see where the rate is less than 50,000. Even that's pretty extreme. Let's look. So among road segments where the crash rate is less than 10,000, we can see, so that if you're reading a box plot, the thick line in the middle is the median value. And then the box itself is it's the range between the 25th percentile and the 75th percentile. Let's filter this down just a tiny bit more. That's wrong. Cutting off a lot of our outliers here. So we can see that the median crash rate, let's take a look at our illumination. Does anyone remember if 2 is if 2 is illuminated or 3 is illuminated?
No light.
2, no street lights, 3 street lights.
Street light.
So our crash rates when illuminated by street lights, looks like the median crash rate is about 500 crashes per million vehicle miles traveled. And then for non-illuminated sections, it looks like the median crash rate is like 200. 200 crashes.
The roads up, everyone crashes.
Is that because the amount of the car is the number of the car on the condition of the light might be larger than the number of the car in the no light street. So the possibility of the occurring crashing is more than the others. Is that the reason of that? I don't know. I'm just guessing.
That's a good guess. I think, I'm a little bit suspicious of the data that we have here. When we're looking here, in theory, a given road segment is either illuminated or it's not, right? Like there's either a light on that road segment or there isn't. And so I'm a little bit suspicious here that we have such an even split between, or in some cases, for the same road segment, we have a bunch of crashes that are either illuminated or not. So here's an example. For this particular road segment, like it's 56,000 vehicles on it a day. There's 11 crashes that have occurred under non-illuminated conditions and 2 that have occurred under illuminated conditions. And I'm suspecting that, so the illumination conditions it's recorded by the police officer who shows up on the screen and fills out the crash report. And so if I had to make a guess about this particular road segment as to whether or not it's under a street light, I would say, reminding myself, 2 no street lights. I would say it's probably not under a street light because the vast majority of the crashes that have occurred on this road segment have been coded as no street light. So I think I want to go through and parse through this data and make an assumption for each TMC about if it's illuminated or not, based on the relative number of crash counts. Now let's do that and then run our rates again and see if we see a little bit something that makes a little bit more sense in terms of our distribution of values. Probably the easiest way for us to do this is going to transform our data from the current long format into a wide format. We do that in R with the dcast command. And so we're going to dcast counts. And we're going to do this as TMC by Illuminati. Our value of R is going to be crash count. All right, so this command takes, we've just summarized for each TMC the number of non-illuminated and the number of illuminated crashes. And so then next we can apply some logic here, and where there's a significant difference between the two, like almost all of these crashes have been coded as illuminated. We're going to assume that this is an illuminated section of road. So we can just apply some logic and say, all right, do we see more illuminated or unilluminated crashes? Like this particular segment is coded 9 are unilluminated. So let's go ahead and I'm going to fill in those NA. We can fill in those NA values with 0. All right, so now instead of having NA values there, we have 0. And then we can just apply a little bit of, just say, we're going to create a value called lighting, and we'll just apply a little bit of logic. We'll say if two is less than 3. So if no streetlights is less than streetlights, then we're going to assign illuminated. Call this lit and unlit. So this little line here, it goes through, and for each row, we need to actually call the column names there. If the value for the number of illuminated crashes is less, for unlit crashes is less than the number of lit crashes, I got that backwards. And something I probably should have done at the outset and didn't do is change these coded values. I could have just updated the values so that instead of working with 1 through 9, we could have replaced this with text for dark streetlights, no streetlights. Let's take a look at this and see if this makes sense. So here, 11 crashes under unlit conditions. That doesn't make sense. I got my logic inverted. All right, so 11 unlit crashes, 2 lit crashes. We're going to assume that this segment is unlit. Here's a segment with 15 lit crashes, 0 unlit crashes. This is mostly lit. So that makes sense. We can look at what's our distribution now of lighting. That's not going to work. It looks like in our data set we have about 1,000 illuminated sections and 200 non-illuminated sections. So now, if we take illumination back out of our counts, we're going to join this. So we just derived a new feature. We derived this lighting feature, and we're making an assumption. I don't know if this is a valid assumption or not. It would be good to go in and look at some of these specific road segments, and like we could look at a specific road segment on Google Street View and look and see if there is lighting in the area. But we're just going to assume that this is a reasonable assignment of a value here. And by actually leave that in place, by making that assumption, that will allow us to better separate out the crash rates between road segments that have lighting on them and road segments that don't. So I'm going to take illumination out, crash count, and then we're going to join this, this value that we just created here back. So we'll create a new data table object by merging our counts here and our CW file. We're only going to bring over the TMC attribute and the lighting attribute from that. And we're going to join these based on the TMC attribute. So both these data tables have a TMC column. This is our unique identifier for the road segment. So now we have our data set in which we have 1 row for each road segment. And we know if that road segment is lit or unlit. And then we have a crash rate. So now we can, let's run our box plot here again. We'll change our data set. Lighting. So when we look at our data here, I guess would someone be willing to give me an interpretation? Oh gosh, I'm sorry. I see we've run way over time. But can someone provide an interpretation of the data that we see here on the screen?
So cool.
Or a best guess about how we would interpret the box plot? So the dark line in the middle is the median. So I would interpret this as saying that the median crash rate on lit road segments is about twice the crash rate on unlit road segments. That's kind of what we're seeing in the box plot.
Yeah.
Ultimately, what we were trying to get to is we wanted to be able to investigate the effect of lighting on a road on crash rates, the number of crashes, controlling for the traffic volumes. And so what we can, I mentioned we might do that with regression. Regression is a great tool to be able to identify quantitative relationships between variables while controlling for other variables. So to get to I guess the end of our analysis here, we're going to use a generalized linear model, and we want to predict the crash count based on the lighting condition and the traffic volumes. And our data for this is going to be our counts. No, our DT data set that has the lighting condition and the crash counts. And then we're going to, because we're working with crash data, counts are typically distributed, are typically modeled using a Poisson distribution. Oftentimes crash counts are modeled with a negative binomial distribution. But to keep things simple, we'll just we'll fit that with Poisson. And so our here's a summary of the model that we just fit. The average number of crashes for a given TMC segment is 2. And this AADT number is kind of crazy. Let's try and bring this into a more reasonable scale. Right now, saying that for each 0.000001 increase in daily cars, there's 1 additional crash. That's not like super meaningful. So we could either log transform AADT, or we could multiply AADT by turn this into annual. The minimum we could turn it into annual traffic. Making things worse. Okay, so sorry. So in interpreting this model, we have a dummy. So we have an intercept term, which is the average number of crashes, everything else being equal. So for a roadway that has 0 traffic and is in lit condition, the average number of crashes in our data set is 2. And that's a data set across 5 years. So, talking roughly about 1 crash every other year. There's a dummy variable in here for whether or not the conditions are lit or unlit. The default value is lit. So we can see that when the conditions are unlit, controlling for traffic, that on average there's 0.39 fewer crashes for road segments that are unlit than lit. Also note that the and this is our estimate here is of the effect of lighting is highly statistically significant. Our estimate of the relationship between log traffic volumes and crashes is just on the border of being statistically significant. So it's maybe a 1 in 10 chance that this value that we're observing here is due to random chance. And because we're using a GLM model, we don't have an estimate of the overall explanatory power of the model. But that's, it nevertheless does give us a result where we say, well, we actually have evidence that on road sections that don't have illumination, that there is a lower crash rate in the dark than road segments that do have illumination.
Mm-hmm. Makes sense.
Even controlling for traffic volume.
Even controlling for traffic volume. And so this still doesn't make quite sense to, this doesn't make intuitive sense to me. I look at this, I'm like, well, I still expect that we would see, low, if it's a safety intervention, we would expect to see lower crash rates under illumination than in an absence of illumination. And that makes me think that maybe there's some other features of the roadway that help determine when there's illumination versus not. For example, maybe it's not just traffic volumes, maybe it's also the roadway configuration or geometry, like intersections. Like you think about on the interstate, they have lighting near on-ramps. And where do crashes tend to occur? Well, they tend to happen at on-ramps where people are merging into or out of traffic. And lighting tends to be at intersections. And where do crashes tend to happen? Well, it's not in the middle of the road typically. It's at the intersection where you have a conflict point between cars coming from different directions. And so I'm thinking that if we could filter our data set down to only intersections and look at the comparison between crash rates for illuminated intersections versus unilluminated intersections, we might see the expected relationship. But right now, the relationship is that if you're just thinking about roadway illumination, the road segments that are dark are actually have lower crash rates at night than the lit crash rates.
Yes. Yeah. So we could select a specific domain so that will make the outcome more specific, right?
Yeah. I mean, you know what? Thinking about this, with the TMC codes, the TMC codes are coded. There's plus and minus values and P and N values in the codes that indicate if a section is part of an intersection or not. Pretty sure. So if we might actually be able to apply that filter somewhat more easily than I expected. If we were to look at this, oh, is that an intersection? Yeah, that's an intersection. So this little roadway has an N, and I think this little roadway out here would have a minus. Yeah, so the N and P values in the TMC codes indicate if they're part of an interchange. And so maybe we should filter down to just the plus and minus values and get away from our intersections, or kind of separate the two out.
Yeah.
So again, we can do this. We can derive a value called intersection. And we're going to use a little bit of, use a regular expression to code these based on whether or not there is a plus or minus in the present in the TMC value. So this is just, I'm gonna write a little regex expression here, intersection based on TMC. And this will assign a true, false value. True or false value based on if I wrote my code correctly. If it's a plus or minus, intersection is going to be false, and if it's a P or N, or maybe I did that wrong. Definitely did. Because it's all false. Let's try this a different way. EN. Regular expressions. I don't know if you talked about regular expressions or not. They're a
yes.
very powerful tool, but also fickle tool sometimes can be a little bit difficult to work with. All right, so here's P and N. This is all coded as yes being an intersection, and then plus and minus, these are coded as false, not an intersection. So we could take our data set here and then filter down to only where intersection is false. So if we, well, so it doesn't, that actually doesn't seem to make much difference. So we've rejected another hypothesis. So when we look at, when we're controlling for both traffic volumes and whether or not intersections are lit, we're still seeing that the unlit traffic, or the unlit road segments have lower crash rates on average than our lit traffic segments. And I'm not sure what to make of that. So this is the point where we've kind of reached the end of the quantitative piece of the analysis, and maybe we would come up with some additional hypotheses, think of other confounding factors that we're not controlling for that would tend to influence the crash rates, and maybe we could add some additional variables to our data set. Or maybe we come to this point and we have a finding here. Maybe we're working as a safety analyst for a DOT. Maybe we want to take this to a safety engineer and say, hey, look, we have data here that shows that lighting is not, like, we're not seeing any measurable improvement in safety performance. So maybe instead of spending all this money on lighting, we should instead be investing in guardrails and like meet with a subject matter expert to better understand why we might be seeing this particular relationship in our data.
Makes sense.
Wow. Wow.
Well, thank you so much for being patient with kind of going through this.
No, thank you. You provide us a lot.
It's a great gift. My job is going to be to do this in Python. I'm so impressed. It's really a great gift to be able to watch you demonstrate such a large set of skill sets across this whole tool chain. What I would like to propose for the class, and we'll be done here, is that that you think about Mark's tool chain as something that you could use to plan out, make an analysis plan for your project that you might implement this summer if you have time. And so I would like to plan that next Thursday, which is our data visualization class, that we have that as a check-in for both the Viz and the ATE-252 projects, so we can do a check-in time then. And I would like to ask Mark for your permission if we could share this out on our YouTube channel. That would be extremely helpful for data students.
Yeah, of course. And I'll I'll package this code into a repository and share that as well in case anyone wants to go and kind of retrace through the steps.
Oh yes, we will. We'll study it. And so I will post this video on Monday because it takes many hours to process. And just want to thank you again, Mark, for your time and your skill sharing with our data students.
Thank you so much.
Thank you, Mark.
We learn a lot from the R in the QGIS.
Yeah, well, thanks for, I commend you for your interest in the subject, and thanks for
Yes,
being part of the class today.
Thanks. Okay, have a good weekend, everybody.
Thanks.
Okay, bye.
Thanks again. Thank you.
Thanks. Thank you.
Thanks, bye.
Okay.
Thanks, Eric.
Thanks.
Have a
Yeah,
good
we'll talk
week.
to you. Yeah,
Thanks,
on Monday.
Eric.
Thank you.
Yeah, so after our class, we just like join the Zoom, or we're not sure when we're done.
No, just next Thursday. If you could do, can you jump in next Thursday evening?
Oh,
Yeah.
Instead of
yeah, of course.
Okay, so for Viz, we'll do it for Viz.
Oh, we don't do it on Monday, right? It's change time.
So what I'd like you to do is just, get as far down. Let's talk Monday night. I'll give you can you just call me
Okay.
after class Monday?
Yeah, of course. Thank
Okay,
you so
thanks. We'll talk.
much.
Yep.
Have
Bye.
a great week. Bye.
Thanks.